So 14.4, we're going to be talking about solving. I'm going to pose no new content, but rather we're just going to run through 4 examples. So to solve a rational equation, there's a bunch of different techniques you could use to do this. I am only going to show you one. The technique I'm going to show you is, in my opinion, the most versatile and simplest of the techniques. So it can be applied in almost any setting right from jump without having to do much to get started, and is relatively simple to execute. It's the only one I'm going to show you in an interest of keeping things simple. Sound good? The technique we're going to do today is called clearing fractions. The idea is I'm going to multiply both sides of our equation by something so that when I'm done, I have no more fractions left in my equation. Okay? The trick is, what is that thing that I'm going to have to multiply? How do I figure out what that thing is that I have to multiply both sides by? It is going to be the least common multiple of the denominators. If I look at this problem, I have 3 denominators. I have 1, I have x, and I have 1. What is the least common multiple between 1, x, and 1? X, right? Because x divided by x is 1, and x divided by 1 is x. Everybody's okay with that? So I'm going to multiply both sides of my equation by x. I'll distribute through. X times x is x squared. X times 3 over x is x times 3 over x is
3 over x.
Not 3 over x squared. 3x over x, which reduces to 3. And then 4 times x is 4x. Notice now that I've done this, are there any fractions left? No! Good news for us. What type of equation is this that we have left? Starts with a Q.
Quadratic.
Quadratic. To solve a quadratic equation, what's the first thing I need to do? It's got to equal 0. So let's subtract 4x from both sides. Now that I have a quadratic equation equal to 0, I can solve this in using two major methods. Those two are, one starts with F, factoring, and the other initials is QF, quadratic formula. So either of those two is going to be fine. Given the choice, if the leading coefficient of my quadratic is 1, I'm going to try factoring because it's quick, it's easy. So I'm looking for 2 things that add to give me -3 and multiply to give me -4.
1 and 3.
Close. They have to add to give you -4, not +4.
-1 and -3.
-1 and -3. So x minus 1 times x minus 3. I can then set each of those factors equal to 0 and solve. My answers are 1 and 3. But I'm not done yet. So what I started with was a rational equation. I know the domain for rational functions do not necessarily include all real numbers. Sometimes there's some stuff missing. The equation I actually solved, though, was a polynomial whose domain is all real numbers. So it's possible that the solutions I got from the polynomial might be the values that are not in the domain of my rational function. To check this, it's very simple. All I need to do is look at, if I take my answers and I plug them into the x's in the denominator, do I get a 0 denominator? When I plug 1 in for x, do I get a 0 denominator? No, it's just 1, right? When I plug 3 in for x, do I get a 0 in the denominator? No, it would just be 3. Both of these answers are acceptable, and I'm done. Easiest check you'll ever have to do. All we're doing is looking for zeros denominators, right? That's example number 1. 3 more to go. Next example. We're asked to solve this equation, x minus 6 over x plus 1 equals 0. What is the least common multiple that I'm going to multiply both sides of this equation by? Not 0. Not x. Not 1. Not negative 1. Not 6. Not negative 6.
Nothing.
Not x. Not nothing. There is something. Come on in.
Negative x.
Not negative x.
0.
Peyton, this is yours.
0.
Not 0.
Oh my god. X plus 1.
X plus 1 is the answer. If I look at my denominators, I have a 1, an x plus 1, and a 1. The least common multiple of those is x plus 1. That's what I'm going to multiply both sides of my equation by. When I multiply this to both sides, I'm going to treat it as one thing. So x times x plus 1, I'm just going to write as that. What do I get when I take x plus 1 and I multiply it by negative 6 over x plus 1? X plus 1 times negative 6 over x plus 1.
6x plus 1.
I get negative 6. Avery, how do we get that? The x plus 1's cancel out, so all I'm left with is the negative 6. Because I have an x plus 1 in the numerator and the denominator. Pew, pew, they're gone. And then 0 times x plus 1 is 0. So now I'm just going to multiply x times x plus 1 out. I'm left with another quadratic. Can I factor this? Yes, what does it factor to? That is incorrect. Those had to give me 7, not 1. And they also multiply to give me positive 6 and not negative 6.
3 and 2.
3 and 2 multiply to give me positive 6 and add to give me positive 5. That adds to give me negative 5.
Oh. No.
You have the right two numbers,
Oh.
but you need to fix the
Negative
signs.
3 and positive
That adds to give you negative
2.
1.
2 and positive 3.
There you go. That's the 2 we need. We set each piece equal to 0, and we solve. But we're not done. What do we still have to do?
Check.
Check to see if it gives you a 0 denominator. The only denominator with any x's in it is this one. If I plug 2 in for x plus 1, do I get 0? No. If I plug negative 3 into x plus 1, do I get 0? No. So both those answers are A-OK. 2 more to go. Are you guys so excited? I can tell you are.
You're excited?
Yeah, of course. Aren't you?
I guess I am.
Okay. What do you notice that's different about this problem than the previous ones?
There's so many.
There's so many. It's harder. Look at the denominators.
Where?
What do you notice that's different in the denominators in this problem than the previous ones?
Square.
There's an x squared in it. What do you suppose we're going to do with that x squared minus 4x plus 3 piece before we get started?
Factor.
Factor it. Very good. How does x squared minus 4x plus 3 factor?
Negative 1.
Excellent. X minus 1, x minus 3. Now, looking at this problem, what is going to be the least common multiple of negative x minus 1, x minus 3, and then x minus 1 times x minus 3? What is going to be the least common multiple? Let me ask you an easier question then. Let's say we have the numbers 2, 5, and 10. What's the least common multiple of 2, 5, and 10?
5.
Well, no, because 10 divided by 5 isn't a whole number. It's 10.
Somebody I didn't say that.
You didn't say 10.
I said 5.
You said 5. But Reagan said 10 after. Nathan says he said 10. I didn't hear him back there because there was like shouting going on also. But I trust you that you did. Yes.
No.
So notice that you had 2, 5, and then 10, which was 2 times 5, right? The least common multiple was the 2 times 5. Here we have x minus 1, x minus 3, and then x minus 1 times x minus 3. What will the least common multiple be?
X. Minus 1. Minus 3.
X minus 1 times x minus 3.
Ooh.
This is like 2, 5, and then 2 times 5, right? You see the analogy I was trying to make? When I asked you the least common multiple of 2, 5, and 10, that was kind of the same as x minus 1, x minus 3, and x minus 1 times x minus 3, because like the x minus 1 is kind of like 2, x minus 3 is kind of like 5, and x minus 1 times x minus 3 is like 2 times 5. It's like the same pattern, right? You're very convincing. So we'll multiply that to both sides. I'm going to treat that as one thing. What do I get when I do x minus 1 times x minus 3 times 2x over x minus 1? When I multiply x minus 1 times x minus 3 to 2x over x minus 1, what do I get? Not 2x over x minus 3, 2x times x minus 3. Because what's going to happen here, those guys would cancel out, right? So I'd be left with just the 2x times x minus 3. Yeah.
Can I use it often?
Sure. Say hi to Reagan. What do I get when I multiply x minus 1 times x minus 3 with 1 over x minus 3? Yes, 1 times x minus 1. I'm going to write the 1 there. We don't need to have it, but I want to develop the pattern of like the numerator is left and then whatever doesn't cancel out from the denominator. But yes, very good. Thanks, Hannah. And when I multiply x minus 1 times x minus 3 with 2 over x minus 1 times x minus 3, what do I get? 2. Excellent. Everybody's okay? What do I do next? Oops. It should be 2x. I forgot to write the x there, huh? I FOIL it out. Boop, boop. Or multiply it out. Boop, boop. Actually, that's distributing that I'm doing. But whatever. Cool? Combine like terms and move everything onto the same side. There's my quadratic. Uh-oh. What do you notice about this quadratic? It's not helpful. The leading coefficient isn't 1. Oh no! So you could still try to factor this, but it requires that longer kind of factoring. Whenever I see a leading coefficient that's not 1, typically I'm just going to use the quadratic formula because I'm guaranteed an answer. It's difficult to look at one of these with a leading coefficient that's not 1 and tell if it's even factorable. And then the process to factor it is about the same as the quadratic formula. So shoot, I'm just going to take the quadratic formula. It guarantees me an answer. Is that okay with everybody? You guys are so enthusiastic. Come on, we're doing like math today. No, Okay. So negative of negative 5 is 5. Negative 5 squared is 25. Negative 4 times 2 times negative 6 is 24. 25 plus 24 is 49. The square root of 49 is 7. 5 plus 7 over 4 is 3. 5 minus 7 over 4 is negative 1/2. But I'm not done. What do I still need to do? I need to check. So going back to the original equation, if I plug 3 into x minus 1, do I get 0? If I plug 3 into x minus 3, do I get 0? 3 minus 3 isn't 0? Yes, it is. Yes. I'm stopping right here. As soon as it happens once. Once is enough. I don't care if it happens more than one time. I go back and I cross out x equals 3. That can't happen. When I cross these out, they're called extraneous solutions. If it happens that everything is an extraneous solution, you're left with nothing else, you would just say there's no solution. But here, we still have to check the negative 1/2. If I plug negative 1/2 in for x minus 1, do I get 0? No. If I plug it into x minus 3, do I get 0? No, right? Negative 1/2 minus 3 is not 0. If I plug it into both of them, they're still not 0, so not 0 times not 0 has to be not 0, right? So negative 1/2 works. That's our answer. That's all we're left with. One more example. Look at how fast this is. It's almost like I planned for something quick to do today. All right. Another example. Once again, I noticed the x squared minus 4x plus 3 in the denominator. As soon as I see that, what must I do? Great. This factored the same way it did before, negative 3 and negative 1. So what is going to be my least common multiple here for this problem? Anybody got it? Excellent. X minus 3 times x minus 1. I'm going to treat it as one thing. When I multiply it with 2.5 over x minus 3, what do I get? Awesome. And when I multiply it with 0.5 over x minus 1, what do I get? Great. And when I multiply it to the right-hand side, what do I get? Awesome. Then we just distribute things back out. Whoop, whoop. I combine some like terms. There's another quadratic equation. I'm going to get everything onto one side. I'm going to elect to move everything onto the right-hand side because I'd prefer to have that x squared's coefficient be positive 1, so the factoring is easy. So how do I factor this? What are two things that multiply to give me positive 4 and add to give me negative 3? Well, what are the things that multiply to give me positive 4? There's only 4 choices, right? That adds to 5, that adds to negative 5, that adds to 4, that adds to negative 4. What does this tell me? Can I factor this? No! Oh, man. What do I do if it's not factorable? Okay. How do I? Yeah, the quadratic formula is what I have to do. Okay. All right, let's see. What do I get? Negative of -3 is 3, plus or minus. -3 squared is 9. -4 times 1 times 4 is -16. 9 minus 16 is -7. Ooh. What does this mean? Yes, that means we have an imaginary answer. We don't care about imaginary results for rational expressions, so we're just going to say there's no real solution. As soon as I see that I pop up, I'm not going any further. I'm just stopping. Everybody feel good? That's it. That's all 4 of them. What I'd like for you guys to work on for next time be 25 to 32. That's not part of this Sunday's problem set, but the following Sundays. And I'm finished. We took